So this is coming from section 9.5, which is about graphing quadratic equations. And so we cover this because we spent, well, the second exam of the class is basically focusing on polynomials and quadratics. And then last week we learned about graphing, so it's like, let's stick those together as we finish out the class. So that's where we're at here. So our quadratic equation is ax squared plus bx plus c, and that's what we're using when we're factoring and doing the quadratic formula. When you're graphing, you just set that equal to y. And that forms a shape called a parabola, which is basically just a U. Or it can also be upside down and look like an arch. So that shape is called a parabola, which, funny story, I was having a conversation with a colleague, and I won't name names, but he didn't know how to pronounce the word parabola, and so I had to teach him how to pronounce it. So it's parabola. He wanted to say parabola, but it's parabola. So, I mean, I understand math is not his area of expertise, but it just makes me laugh every time I talk about parabolas. So the direction of a parabola, whether it's opening up and looking like a smile, or it opens down and looks like a frown, which rhymes and I love, that is determined by the A, which, again, a parabola is y equals ax squared plus bx plus c. So that value in front of the x squared, whatever that number is, that determines whether it opens up or opens down. And that value, that number, is called the leading coefficient. So if that value is greater than 0, which means that it is positive, it forms a smile. It goes up. So it makes sense. If you're positive, you smile. And if it's less than 0 or negative, well, negative people usually frown. So the sign, it opens up. If it's positive, it opens down if it's negative. So that will tell you the shape based off of the sign of that value. So you can get an idea if you're like trying to pick out which graph matches this equation. That at least can eliminate some choices for you by just determining which direction the shape needs to be. So if you notice here, if it forms like a U or an arch, there's a middle where it has like a reflection, like it's basically symmetrical on either side. So that is referred to the center, or called the vertex. That is the order. The vertex is specifically an ordered pair. So it's the exact location, oops, h, x comma y, or it's sometimes h comma k, but it's the exact location where it changes direction and it starts turning back away the same direction it came. So that's the halfway point, basically. So you can use that property when you're graphing because you know that it's going to be a mirror image. And the x value can also be used to get an equation of a line. We can get a vertical line because all vertical lines are x equals a number. So the axis of symmetry is just x equals h, whatever that x value is for that vertex. And then it just forms a line where you'll have your mirror image. So just some terminology there. So finding the vertex. So there's an actual formula for this, and it may be familiar. So remember that the quadratic formula we talked about is negative b plus or minus b squared minus 4ac all over 2a. Well, if you don't have any of that stuff underneath the square root, and you would just have the negative b over 2a, and that's actually where we get the x value of the vertex. So that actually comes, it's related to the quadratic formula there. So that is negative b over 2a. So that can help you remember And you're just basically plugging in the same numbers that you did when you had to solve the quadratic formula. It's the same values for B, the same values for A. You're just leaving off all the square root garbage. So that will give you your X value, your input, and then you have to plug that back into the equation to find Y, because the vertex has an X and a Y value. So once you find X, you have to plug it back in to get Y, and then you have the ordered pair. So that brings us to the graphing, the actual graphing process here. So when you're graphing, the first step is just to determine the general shape, whether it's going to open up or down. Then you find the vertex, because that will tell you that middle point so that you know the general shape from there. And then it's good practice to find the X-intercepts. So that's where you would set your equation equal to 0. So you would ignore the Y, set it equal to 0, and then you solve for X. So that's where we had to do the factoring or use the quadratic formula. So that's what we did in week 6, where you had to solve quadratic equations. Once you have your X-intercepts, then those are where it is on the X-axis, and you can plot those points. And then it's good practice to also find the Y-intercept so that you know exactly where it crosses on the Y. And to do that, you plug in X equals 0. And once you get that Y, then that should give you, usually there's 2 X-intercepts, a vertex, a Y-intercept, 2, 3, that's 4 points. And usually with the Y-intercept, you can then use a mirror image to get a 5th point, so that way you can get a good shape. And so then you just connect them all, and that gives you your parabola. Most of the graphing we're going to be doing, you can just do in Desmos. You don't have to really do these by hand, but I'm going to do them by hand just so you can get practice with the process. The important thing for you guys are to be able to calculate these things. The graphing part, let technology do it, but at least you need to be able to how to find these values. So I don't have too many examples, because again, you're going to just use Desmos for most of these things. So I've got a couple examples here. So we have y equals x squared minus 4. So our quadratic form, ax squared plus bx plus c. So it's always good to just identify your a, b, and c, because you're going to need those. So a is what's in front of the x squared, so that's 1. B is 0, because we don't have that middle term with the x. And then C is negative 4. So you determine whether the parabola opens up or down based off of A. So A is equal to 1, which is a positive number. So that means it's going to open up. So you know the general shape. Next step is to find the vertex. So this is where we're going to use the vertex formula. So that is x equals negative b over 2a. So I already wrote down my a, my b, all of that. So negative 0, because b is 0, over 2 times 1. So negative 0 is 0. 2 times 1 is 2. 0 divided by 2 is equal to 0. So we have our x value of the vertex, but the vertex is an ordered pair. You also need to find y. So we need to plug that number into our equation. So we have y equals x squared minus 4. So you're going to plug 0 in for x. So we get 0 squared minus 4. 0 squared is 0. So that's just 0 minus 4, which is minus 4. So our vertex is an ordered pair. 0, negative 4. So that is your vertex here. Next, we're going to find the intercepts. So we're going to find the x-intercepts first. And coincidentally, because our x value is 0 here, this is also the y-intercept. So we don't need to do that because we already found it. But we do need to find the x-intercepts. So that's where you set your equation equal to 0. So we set y equal to 0. So we get x squared minus 4 equal to 0. So this is actually something that we can solve by taking square roots. So if you remember that from week 6, you can get your x squared by itself and then take the square root of both sides to get your values for x. So that's what we're going to do because that will actually be easier here. So I'm going to add 4 to both sides, which gives us x squared equals 4. So then we want to take the square root. So you're taking the square root of x squared and also the square root of 4. And I'm adding the plus or minus because remember, when you're solving for x and you take a square root, you have a positive and a negative. So the square root and the square cancel, and I have x. And then the square root of 4 is 2. So that's plus or minus 2. So our x-intercepts are -2, 0, and 2, 0. So now I'm going to graph this by hand, even though we can use Desmos, but I just want to demonstrate how we can do that. So we're going to graph y equals x squared minus 4. This will just be a sketch because I don't have a grid here, so it's not going to be pretty. But I'm going to label my key points. So we had our vertex at 0, -4, so I'm labeling that. And then our x-intercepts are at 2 and -2. So the vertex is the middle. So it's either going to be, and we know the shape, we knew the shape was going up. So that means that vertex is going to be the bottom of the U. So I have to sort of make it look like it's forming a U. And we have to make sure it goes through those x-intercepts. I'm not perfect here. So we use that shape so it kind of helps us what direction to go. And that's what our parabola looks like. The axis of symmetry, the part where it reflects, is at x equals 0. You can see that y-axis, which is where x is equal to 0, it forms a mirror image across there. So that's what the graph looks like. Something you can verify on Desmos. And Desmos is really nice because when you click on it, it will tell you all of these points. So you can also use that to double check your work. Okay, so I've got a second one here. And we're going to identify our A, B, and C. So A is -1 because we have a negative x squared. So since there's no num there, it's going to be a -1. B is 10, and then C is -25. So in this case, our A is negative, which means it's going to open down. So we're going to keep that in mind while we're graphing. So we want to find the vertex, and it's always good practice to write the formula. It's -b/2a. So b is 10, so that's negative 10 over 2 times negative 1. So that's negative 10 over negative 2, which gives us 5. So x is equal to 5. Now we want to find the y value. Good, Corey. Glad you remember how to do these. And welcome, Samantha. So we just started this example. When I mail out the recording tomorrow, that will allow you to kind of catch up and see what you missed. So x value here is 5. We need to find the y value because the vertex is an ordered pair. So I need to plug that into my equation. So y equals negative 5 squared plus 10 times 5 minus 25. So negative 5 squared. 5 squared is 25, so that's negative 25 because the negative is outside of the parentheses. Then 10 times 5 is 50, so that's plus 50, and then minus 25. And negative 25, negative 25, that actually all cancels out to 0. So that gives us our vertex here as 5, 0. Next step is to find the intercepts. So we're going to start with our x-intercepts. That's where y is equal to 0. So I'm going to have 0 equals negative x squared plus 10x minus 25. Now this is something that we can, let's see, can we solve this by factoring? We can solve this by factoring. I would actually, usually you want to have your x squared positive so you can move everything to the other side or just divide both sides by negative 1. And that will switch the sign. So that would be like x squared minus 10x plus 25. So that would be equivalent if I just moved everything to the other side, because we'd like to have a positive in front of the x squared when we're factoring. So this factors, we have an x times an x to get us x squared. 5 times 5 gives us 25, and then to make it add to a negative 10, both of these have to be negative. So you can see that these are identical, so we really only have one x-intercept. And so that's going to be where x minus 5 is equal to 0, which gives us x equals 5. So as an x-intercept, we have 5, 0, which is what we actually found with the vertex. It's also the vertex. So it's both, which is totally fine. So when we find our x-intercept, next is to find the y-intercept. And that is where x is equal to 0. So you're just going to plug 0 into your equation. So a negative 0 squared plus 10 times 0 minus 25. So 0 squared is 0, negative 0 is 0, this is just 0. 10 times 0 is 0, and then we have minus 25. So this is negative 25. So this gives us 0, negative 25 as an ordered pair. So let me just label all of these things, make sure they're boxed so they're clear. So we know that our parabola is going to open down. We have found that the x-intercept and the vertex are the same point. And then we have found a y-intercept. So I'm going to sketch this. So we want to graph y equals negative x squared plus 10x minus 25. So I'm going to count by fives because our y-intercept goes to negative 25, and I don't want to have to count that far. I still already have to count pretty far. If I'm scanning, so let's see, 5, 10, 15, 20, 25. There we go. So we have our vertex was at 5, 0. And that is also an x-intercept. And our shape was going down. So we know that the vertex is up here. So that means the shape at this point is going to look roughly like this. So I like to fill it in so that I know. We found a y-intercept at negative 25. So that means my graph has to go through here. And now the nice thing is that this forms a mirror image. So because the distance from our y-intercept here is 5, that means 5 in the other direction is going to give me a mirror. So that means that I also have a point right here because it forms a reflection. So you can use that property, that reflection, to get another point to help you complete your shape. This is not to scale because I don't have a grid, but you can see the general shape there. And you can use Desmos to get a much better graph than I have. But that's basically how you sketch these things. Do you guys have any questions on the sketching or finding those values that I found, the vertex or the intercepts? Okay. Now I'm going to finish off with 2-word problems because that's where these things actually come in handy and are used, especially in business. Is actually these quadratic equations show up a lot in business. So we've got a concession stand that sells a hamburger drink combination dinner for $5. The profit Y can be approximated by this equation. So if you were to graph this equation, that would give you an idea of what your profit will look like. Now, the value in front of the x squared is negative, so our profit equation is going to look like this. It's going to be a down shape. And that makes sense because you don't have infinite profit. If you think about how this might work in business, is let's say it was centered at 0, 0, which this one's not, but let's just say it was. Let's see, so X here is our number of dinners prepared. So if you make no dinners, you're going to have no profit. So it's going to make sure it makes sense it would be 0 at the origin. This one's actually at 0, it's negative 400, which the 400 would represent that even if you don't make any dinners, there's $400 probably for fixed costs. Maybe that's electricity, rent, whatever it is. There's going to be some point where you're going to make a number of dinners and you're going to come out with a lot of money, some maximum value up there. But then there's going to be a point where you make too many dinners and you don't sell them all and now you've lost money. So your goal here is you want to maximize your profit. You want to find that peak where you make just enough dinners that you don't start losing money from unsold dinners. So that's why this is this shape. If you think about how supply and demand works, you know, sometimes you have too much, and you can do this even with price. If you have too many things, price starts going down. You can't sell it for as high as you could before. So X here is dinners prepared, so I should just label this so that you know what that means. and then the Y is the profit. So the question is, how many dinners should be prepared to maximize profit, and what is the maximum profit? So the maximum profit is the vertex. So that vertex where we're at the peak and then we start going back down again. So we are looking for the vertex here. When it's asked for a maximum, or sometimes it's asking for a minimum, that's always going to be the vertex. So we need to find the vertex. So the formula is x equals negative b over 2a. So we should identify our a, b, and c. So our a is negative 0.001. So that's the number in front of the x squared. B is the number in front of the x, so that's 3.6. And then c is negative 400. So to find the vertex, we don't care about c. We just want a and b. So I'm going to plug those in. So we have negative and then b, so that's 3.6 over 2 times a, which is negative 0.001. So this is a real world problem. So you're going to have decimals and you're going to want to divide. You're not going to want to try to mess with any fractions. So we have negative 3.6, and then 2 times negative 0.001 is negative 0.002. So the negatives are going to cancel, and you just do 3.6 divided by 0.002, and we get 1,800. So this is how many dinners you need to prepare in order to get the maximum profit. So since this is a word problem, we'd like to answer this in a sentence. So 1,800 dinners should be prepared to maximize profit. Now the second question says, what is the maximum profit? That is the Y value. That is what we want to find, the Y value at the vertex. So we need to plug 1,800 into our equation to find out what Y is. So Y is equal to negative 0.001, and I need to plug in 1,800 and square it, plus 3.6 times 1,800 minus 400. So calculators are definitely needed here. So 1,800 squared is a really big number, and I'm not going to write that down. I'm just going to immediately multiply it by the negative 0.001, because that at least makes it easier to write down. So that's negative 3,240. Now I'm going to do the 3.6 times 1,800. That's 6,480. And then we have minus 400. So now we just add all of that up. That gives us 2,840. So Y is profit. So the maximum profit is $2,840, or $2,840, however you want to read that. So we've got our two answers. 1,800 dinners should be prepared, and the maximum profit is 2,840. Are there any questions? Okay, so this is another word problem. This is my last example. Kite surfing is an extreme sport where athletes are propelled across the water on a board using the power of a kite. Josh loves to kite surf, and the height of one of his jumps can be modeled by y equals negative 16t squared plus 32t. So I'm going to draw a picture. So we've got the water, and Josh is basically jumping out of the water, and then he's going to come back down. So he's forming a parabola. And this equation, the negative 16 actually is, this whole equation actually comes from physics. So it is modeling your vertical height, basically. There's a physics equation for modeling vertical height. The negative 16 part comes from, it's negative 1/2 times the acceleration of gravity, and gravity is 32.1 feet per second squared. So this is actually comes from real data. This is a model that can be, I'm sure the 32, that would be probably 32 feet per second times whatever angle he jumped out of. So that would have to depend on the angle. That's how they came out with the 32. But we've got this model. He's jumping, and then he's landing back in the water. In this equation, y represents Josh's height in feet, and t represents the time in seconds after launch. So he goes up, and then he comes back down. So our first question is, how high will Josh be in 0.5 seconds? So they're telling us t is equal to 0.5. So all you need to do is plug that into the equation to find y, because y gives the height. So y is equal to negative 16 times 0.5 squared plus 32 times 0.5. Don't really need to write that y again. So 0.5 squared is 0.25 times negative 16, and that gives us a negative 4. And then 32 times 0.5 is 16, because that's half of 32. So then negative 4 plus 16 is 12. So y is height in feet, so he is 12 feet high after 5 seconds. 0.5 seconds, not 5. Which is a massive jump, but if you're being propelled off water with wind, you're going to have a lot of momentum that's going to allow you to jump that high. Second question here is, what is Josh's hang time? So hang time is how much he's in the air. So in order to find the hang time, we want to know how much time does it take to go this distance, basically. When do we start, or when do we launch off the ground or off of the water, and then when do we land again in the water? Because when he lands back into the water, that's the difference between those two times is going to give you the amount of airborne time, because he was airborne between those two times. So we're actually looking for the intercepts here. So that means we need to set our equation equal to 0. Especially because when you think about it, if 0 is y, that's the height, then when you're landing again, your height is 0. So we have 0 equals negative 16t squared plus 32t. Now to solve an equation like this, because there's no c term, we have only things with t. This means we can factor out the greatest common factor, and that will give us an easy way to solve this. So I can factor out a negative because I have a negative in front. And 16 goes into 16 and 32. So I can also factor out a 16 and a t, which leaves me with a single t and then a minus 2. I almost put 1. 32 divided by 16 is 2. So we get a negative 16t times t minus 2. So we're solving for t, we're solving for the time, so we set each of these equal to 0. So we have negative 16t equal to 0, which when I divide both sides by negative 16 gives me t equals 0, which makes sense because he launches 0 times after launch, or 0 seconds. So at time 0, that's when he launches. Then our second equation is t minus 2 equal to 0. And when you add 2 to both sides, you get t is equal to 2. So that's when he lands again. So he launches at 0 seconds, and then he comes back down to 0, or hits the water at 2 seconds. So his hang time is between 0 and 2 seconds. So that means that he was in the air 2 seconds, because that's the difference between those two times. So Josh was in the air for 2 seconds. So that's his hang time. Are there any questions? All right, so that was my last example. And Brittany, you just joined, but I just finished my example. So you're going to want to wait for the recording to watch that. So Corey, do you have any questions?
I figured I was too late.
Yeah, I waited, and Corey came on because he felt bad for me. He came on, so then I was like, oh, somebody's here, I can actually get started. But I do appreciate that you popped on to see.
It's okay, my phone even started to die. I had to come out to my car.
Oh, yeah. I'm just glad that I wasn't talking to myself.